Hello and welcome to Statistics 1. There's going to be part 2, like the revenge of statistics or something like that. So, what is stats? Well, first off, this is going to be the introductory statistics course, which means no calculus in it, which means it's not transferable exactly everywhere. There is a calculus-based statistics, which you take after you take Calc 2. So some of the majors would require that. So pay attention, right? In this introductory course, we are going to learn about stats, the basics. And as I mentioned when we talked about a syllabus earlier, 100% of problems in this course are word problems. So I hope you are loving that already. Statistics is study of data and trends and analysis of that data. So it's very useful. It's useful in every single field, and it's studied because we like to conclude and predict the future by looking at our past experiences and our past measurements. So we can look at ratios, we can look at data sets on sales, sports. Obviously, analysis uses a lot of this. In finance world as well, there are a lot of predictions coming up. So the course is going to actually see all branches of our life. Problems are mainly like sharks and death, I noticed, but we'll try to lighten up the mood with housing and salaries or that's grim too. I don't know. The book is dark, which is I like it, right? The book is dark, but it's all about death and car accidents and sharks and stuff. So we'll see how that goes. Well, the first problem is baseball, but I'm not a big sports fan, so I'm just going to skip that, right? All right. So statistics, study of data, analyzing data, predictions, and all of that, and it's so let's go with not Stan. Stats. There we go. Study of data, analysis of data, predictions, and we're also going to have some probability. There will be one chapter on probability, which is chance. Where we learn that we are not supposed to waste money on any type of lottery and stuff like that. But we'll see that when we get there. I know someone is going to say, but someone has to win. Well, guess what? It's not you. Someone, yes, but not you. And we'll talk about that. We'll also see in that section why, even if you go and let's say you are that crazy lucky to make $10,000 in casino every time you walk in, why is that insignificant for a casino? Why would they always make money and why you will always lose on average? So we'll talk about all of those things when we hit the probability chapter. We will also see why pizza is always going to make it to your house faster than the ambulance. That's another thing that it's also cool to calculate, and a lot of other things that improve the quality of life, right? So now, stats is divided into two different branches, let's say, and one is descriptive statistics. Descriptive statistics, I'm going to change the color of this other arrow. Let's use green because we can. The other one will be inferential statistics. So let's first talk about descriptive, very brief explanation for it. So for descriptive statistics, you are only describing the data set you have. Now, data could be numbers, it could be names of people, it doesn't, or objects. It doesn't have to be just numbers. So when we are talking about descriptive statistics, we have the data and we are just describing the data, reading, understanding the data. So descriptive statistics is well, actually, you know what? I can probably steal the definition. Descriptive statistics consists of methods for organizing and summarizing information. Perfect. So descriptive stats, methods of organizing and summarizing information. Now, this word information, I'm just going to say data in parentheses because data sets is what we are concerned with. You go and you collect data. Who voted, what candidate, or as simple as, it's not polite to ask you how old you are, but I can ask you what is your body weight. Obviously, that's cool. So those are kind of things that we can do. Now, inferential statistics is going to predict the future looking at the data you have. So inferential statistics infers, right? So inferential stats, that's going to be green over here. Inferential statistics will, I'll just write predict. There is a formal lecture for this coming up, so we'll redefine it. Predict the future looking at the data. So in order to do inferential statistics, and that's going to be very end of our course, we have to have data and we have to have the descriptive statistics done because if you ask me, okay, what is the ratio male to female taking statistics course? Well, I don't know. I have to do the measurement. And the measurement is, I have to go to each class we have. I don't have to go to each, but we'll talk about sample and population. And count. How many male, how many female in each classroom. And then come up with that data set. It could be 50-50. It could be 55-45. It could be 65-35. We don't know until we do those measurements. Now, if I am, luckily I'm not, administrator at the college trying to figure out the ratio, then the decisions for the college have to be made and statistics needs to be known. So if you're making a decision, you're not making decision for the past. You are making decision for the future. So administrators have to deal with inferential statistics. They have to deal with the descriptive statistics to understand the current state and what the data and the data trends show to conclude, predict, and take a look at the future. This is why statistics is so powerful and so important in many fields. So that's what the stats is. It's not just number crunching, but for the most part, number crunching. And understanding what those numbers tell us, and then taking the descriptive statistics and data sets, and then making predictions about the future so that we can make better decisions in terms of business, in terms of running whatever. Those are or just if you want to bet on a team, sports team or whatever, you use statistics to. One thing, you can't use stats for is to play lottery because that doesn't work. But in case of whatever that pick 4 or whatever, I think 10,000, 1 in 10,000. You ever have to buy 10,000 tickets to ensure you win daily. You can't buy 10,000 tickets in a day physically. It's possible. So that's why they can run that. So now in section 1.1, we are talking about this descriptive statistics. And we have to define some of the terms before we do anything else. Every time I use red, that means this is extremely important. So the definition for population. We will be dealing exclusively with population and sample as we go through the course, and that will be the first thing for every word problem you do. You will always first ask yourself, are they talking about population or are they talking about sample? Because you have different formulas. So you will learn formulas for population, you will learn formulas for sample, but if you don't understand the difference between sample and population, you're not able to recognize the difference within the word problem, you might use the wrong formula, leads to different answer, leads to need for tissue box. So we want to get these definitions right off the bat. So population, the collection of all individuals or items under consideration in a statistical study. The word all is the one that you have to underline. So population is the collection, much better to say the set, but the collection of all individuals or items under consideration in a statistical study. Immediately after that, we go with sample. So we have population and we have sample. Sample is that part of the population from which the information is obtained. Not too happy with the definition, but so that part, the word part, of population from which information is obtained. So these are two most important definitions of the entire course. And as I mentioned, you will be dealing with these two definitions in every single problem, Stats1 and Stats2, because population and the sample have similar but different formulas to calculate things. They have different notation as well. For instance, if you use numbers, the population would be described with capital N, sample would be described with a lowercase n. Capital X, lowercase x, capital X bar, lowercase x bar, and all of these things. So it will be used a lot. Make sure you understand this. Now let's talk about population and sample and in which way they are different. So population is all, and sample is part. So that should be the first thing to get stuck in your brain. If I am talking about all students signed up for this course, this section, then you are population. However, at the same time, you are a sample of a bigger group, which is, let's say, all students enrolled in statistics. There are other sections, right? And that could also be a population, because you can say all stats students at RVCC. But then that is also a sample at the same time, because you have all of the students that are taking math courses. And then you have all the students that are enrolled at RVCC. And then you have all of the students in New Jersey. And then you have all the students in the US and the world. See, there's always a bigger fish, right? So you have to define what you are talking about. And within that definition, you say, okay, this particular set of people or items or whatever is population or is a sample. So you see that you as a group in this classroom, you can be considered population if I say all of the students of Math 110 dash whatever our 06, wow, thank you, statistician. Oh, okay. 06, all right. So 06. So you are population for Math 110-06. You are a sample for Math 110, because there are other sections, section 01, section 02, 03, and so on. So we have to be careful about that. Within this population, we can find smaller samples. I pick every third student. That would be a sample of our class. The way we are going to have a whole lecture on the way we obtain samples, because that's not actually trivial work. We have to know exactly in which way to pick samples so the sample is random and sample is useful. So population and sample, those are the first two. And here is the inferential statistics. Consists of methods for drawing and measuring the reliability of conclusions about the population based on information obtained from a sample. Population is just too many words. You're predicting the future. All right. So you are taking the descriptive statistics, and you are, as I say, the methods for drawing and measuring the reliability of conclusions about. So you are technically taking all of the data that you have, and you are inferring what's going on. Well, we'll do problems for that. So now there is a cool graphic as in a textbook. As you can see, this graphic shows population would be all, which is that bigger square, and then you have the sample, which are certain surveys. So you have, for instance, in United States, do you know what's the name when they're surveying entire population? What's the name for something like that? Census. Very good, right? When they mention census on, right, they're going to go around and ask everyone, right? This is where some people go, not me, right? But voting is not census. Some people just don't want to get up and don't vote. So that's about it. So that's the difference between population and sample. So we have, so to classify these statistical studies, we have descriptive ones, we have inferential ones. Descriptive study may be performed either on a sample or a population. Only when an inference is made about the population based on information obtained from the sample does the study become inferential. So you are inferring about some characteristic about the entire population, right, regarding just looking at the particular sample. So if I am to go around and ask 10 people, do you like math or do you like stats? and those 10 people say, 9 out of 10 say no, I will infer for the entire classroom that you don't like math or stats, because 90% of the sample said, right? So I'm predicting that I'm not going to have a great class because 90% of you don't like it already, out of box. We haven't even had proper lectures yet, or problems, or homework, or nothing. See, so I'm predicting misery in the future by using inferential statistics. Does it make sense? Yeah, it's called application, right? Day one. So classifying statistical studies, let's write that down. And we have 2 of these, so we're going to have the descriptive study and the inferential study. No coffee. Or sniffling. So these are the 2 studies. Descriptive study is going to take the data and just analyze it, find mean, median, mode, 5-number summary. We have a whole chapter devoted to it, so you will know. And then inferential study is the one where you look at the sample and you make conclusions about population for whatever decisions you're going to make. So you survey 10 people, and then you make a conclusion about 30 people, and their, or 40, whatever. So now to illustrate this, I'm not going to talk about problems that are worked out in a book. I'm going to run into homework and just take a look. So now let's see. So classify each of the studies as either descriptive or inferential. Let's go with the professional athlete salaries. So from the statistical abstract of the United States, in the article average salaries of the NBA, NFL, MLB, and NHL, by J. Dorish, whatever, published on the Yahoo Contributor Network. Well, that is the little explanation, right? We obtained the following data on average professional athletes' salaries for the year 2005 and 2011. And there's the table, the one small in the lower left, shows baseball, basketball, football, and then it shows numbers. Average baseball salary for a year was $2.5 million. Average basketball is $4 million. Average football, 1.4. Well, it's about 1.5. And then we see that all of those salaries being larger 6 years later at 331, 515, and 1.9 million on average. So the question is this study descriptive or inferential? And why? If you pick one, just say it.
Already happened.
It already happened? What else? Yes?
Using data that you already have.
Data that I already have. Okay, what else?
It's an observation.
It's observation. What else?
It's just the numbers without inferring.
Yes, we're not inferring. Okay, good. What else? So yeah, all of that you said, it's great. This is the data that it's collected. It's just displayed. It is not making prediction of what would... We were not using this data to make prediction about tennis players, right? On average, they make about $130 million a minute. Or golf or anything like that, right? So this is not inferring about salaries of any other sports athletes looking at this. So pretty much that's it. Let's see. See, there we go out talking about drug use, home sales. They have John Doe industry average. In-demand college majors. All right. In a June 2013 article published online by The Street, B. O'Connell discussed the result of a survey and opportunities for graduating college students. In one aspect of the survey, the following percentage estimates were reported on which the college majors were in demand among U.S. firms. So this is what the U.S. firms, right, the employers, are demanding. Business studies, 31%, computer science, 24%, engineering, 17%, healthcare sciences, 10%, engineering technologies, 9%, math and statistics, 9%, communications, 7%, education, 7%, science, technology, and liberal arts, 6%. Do we see any issue here on the demand and supply? What's the biggest major group on every college you have? Liberal arts. What's the least amount required from the companies? Yeah, right? Okay. Well, now that we got that out of the way, is this data descriptive or inferential, and why? This study, sorry, not data, study. Yes?
It's descriptive because it just predicted sort of plays everything out.
Perfect. That's all you have to say. It's descriptive because it's not inferring anything, it's not predicting anything, it's not giving you any advice. It's just bleh. There you go. Right? Done. And walk away. So you look at this, you learn from it, right? You learn from it, but it doesn't infer anything about anything else. So, good. What else do we have? Big Ben's breakup, genocide, prostate cancer, heart failures, aspirin. Told you, right? The book is a winner. Sex, sleep, and PTSD. There we go. Let's see what else we can find. Ballistics fingerprinting. Sounds cool. Causes of death. Let's do that one. Sounds cheerful on day one. Why not? Right? Causes of death. The National Center for Health Statistics published the following data on the leading causes of death in 2010 in National Vital Statistics Report. Deaths are classified according to the 10th revision of the International Classification of Diseases. Rates are per 100,000 population. Disease of the heart, malignant neoplasms, chronic lower respiratory diseases, oh my God, something vascular diseases. These are the accidents, and then Alzheimer's disease and diabetes. Descriptive, right? It doesn't tell you, you're going to die on October 7th. It just say, okay, these are the deaths. So it's descriptive. I'm trying to find one that's inferential. Medical testing on animals. That's grim, but it goes with the rest of the vibe of the book. Started at 59. So in summer of 2013, Animal Action Report, the National Anti-Vivisection Society stated that 59% of Americans between ages of 18 and 29 oppose medical testing on animals. The percentage of 59 was computed from sample data. Okay, without going through A, B, C, D, would something like that be inferential or descriptive? Descriptive. Why? What was given to me?
The percentage of Americans that have closed animal testing.
Okay, who are Americans now? All Americans? All of them? Does anyone recall being asked by these guys about animal testing in this classroom? No? What does the last sentence say? See? Welcome to hell. The devil is in the details. The percentage of 59 was computed from sample data. They infer that 59% of all Americans have this opinion, right? Clearly they didn't pull too many from the south or the inner parts, right? So this is an example of inferential, because the sample is looked at and they're claiming that the 59% of all Americans between these ages have this opinion. It doesn't necessarily have to line up, but it's the best we can do, so we roll with it. That sound good? So when you take a sample and you ask smaller sample, that small sample could be 1,000 or 10,000. It's a small sample, because in a population of 320 million, what is 10,000? It's nothing, right? Nothing. About 35,000 dies only in car accidents a year. 35,000 Americans. That's just car accidents. We're not talking about any other cause of death. So 10,000 to be surveyed as a sample for something as large as population of US is nothing. 100,000 is getting somewhere, right? So all of those, that's why those presidential election polls and all that stuff is so expensive, because you have to reach hundreds of thousands of people to have some prediction on who's going to win elections, and it still is going to be wrong, right? So when you look at this example, there we go, 59% of Americans between 18 and 29, there are going to be a lot of, that's going to be in millions, the amount of people that are 18 to 29 of age. So that's millions. They did not survey all of them, because that would be like census, but only for these ages. So they didn't. So they took the part, and they looked at the part. The part said, okay, 59% says it's bad to test on animals, and then they infer that 59 of all Americans in this age have that opinion. We are going to have an entire chapter that will correlate this and tell you how good of a prediction you are making. We'll have an entire chapter to play with these things. So that's what we have for classifying these studies between descriptive study and inferential study. So descriptive study is the study of population, where you survey your population, you learn something about it, and you're happy. And then inferential study is the one where you look at the sample, you infer about the population, so you can make future decisions and so on. Historically, the statistics appear to be inferential statistics. Census were taken as long as ago as the Roman times. So we are talking about year 0. Over the centuries, records of such things as births, deaths, marriages, and taxes led naturally to the development of descriptive statistics. So we have that. And more examples. Well, that's it. Bye. That's it for this one.